Welcome to part 2 of our chemistry notes. If we remember part 1, we ended up by talking about Dmitri Mendeleev. Dmitri Mendeleev is known as the father of the periodic table. And the reason he was known as the father of the periodic table is he was able to take all the elements that had been discovered so far, and when he examined them and he looked at the properties, he was able to arrange them. And not all the elements had been discovered when Dmitri did this. And neat thing about when he put this table together, there's actually gaps or spaces left in the periodic table because none of the elements that had been discovered so far fit in this periodic table. So in a way, he was predicting that these spots would be filled in the future with new elements that would have been discovered in the future, and he obviously was correct. Now, when we think of periodic tables, we don't usually think of periodic tables like this. It's not your traditional periodic table, but it does show the elements. And there's different periodic tables out there used for different purposes, used for different disciplines. But this is probably one of the ones that you're more familiar with. At least this shows the column. But this is a neat periodic table because if you look at it, it actually shows the pictures of the elements. So if you were wondering what it looked like, this would show you what it looked like. Now, some of them obviously show other ideas of what it is. For example, when we look up here in the corner at hydrogen right here, when you look at that right there, that's not necessarily what hydrogen looks like. It's not a nebula, it's not a gas like that, but it is a gas, so it kind of gives you an idea of what it's like. But this is more of a periodic table that you're used to seeing, where you've got your hydrogen, you got your helium. If you look in front of the classroom, or if you look in most science classrooms have a periodic table of elements. So what do we know about this? Well, 90 of these elements are naturally occurring. Now, when you see this number 90, that is debated. A lot of times, you'll see a different number around with this. So, even though this says 90, a lot of times you're going to see the number 92 along with it. Oh, sorry, we had some technical difficulties there. So when you see this 90 here, a lot of people come up and they talk about it being 92. And so there is some disagreement amongst scientists. Is it 90 or is it 92? So I've read some textbooks where they talk about 90. I've read books where they talk about 92. For all practical purposes, just use the number 90 in here and you will be okay. Now, what about all these other elements? If you take a look at the periodic table in the front of the room, it's a little bit older, but there's definitely more than 92. If you take a look at the periodic table in your student planner, it's probably going to have up to 118 different elements in it because some of the elements have just been discovered recently. And not necessarily discovered as far as them being out there in nature, but they were actually produced by scientists. So they were created by humans in the lab. Now, most of these elements in a periodic table are solids. So they're not gases and they're not liquids. Some are found as gases, a few, and then a very, very few are found as liquids. In fact, there's only 2 elements that are liquid, bromine and mercury. So let's take a look at this one right here, groups or families. And I already had families kind of circled here. Now there's actually 2 names that are used. The more common name that I'll use most of the time is this, groups. But families can also be interchanged with that. And when we look at a periodic table, here's a blank periodic table. And all elements in the same vertical column are said to be in the same group or the same family. So when I look at this right here, when I look at the column here, and there's an arrow coming down here, we actually, if you want to call the group, it's actually group 1. This one is group 2. Here we have group 3. And if we continue to go over, we got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. In fact, if we keep counting all the way over, we're going to get to 18. So if I ask you a question in class like, what elements are in group 18? Well, it's pretty simple. You just look over here, you count out all the way over. Okay, here's the 18th. So these are the ones that are in group or family 18. So the vertical columns, the up and down columns, the ones that go up and down, these are called groups or families. So what about the horizontal rows? And you see some of those horizontal rows right here. Here's one. These are called periods. And one of the ways I remember that these are periods and keep periods and groups separately is I look at a period. Where do you find a period? The period is at the end of a sentence. Now when we write a sentence, sentences go across the page. Sentences don't go up and down the page. So I always remember periods. Okay, there's a period at the end of a sentences. Sentences are horizontal. So all elements in a horizontal row are said to be in the same period. And much like these were the groups, group 1, group 2, the periods go the same way. This is period 1, this is period 2, this is period 3, this is period 4, 5, and 6. Now each family has its own property characteristics based on the number of valence electrons. If we back up just a little bit, now we call these things families. Why do we call them families? Well, take a look at your own family. How many of you have a brother or sister that I've had in class before? How many of you have ever been mistaken for your brother or sister? How many of you have ever been in a situation where someone looks at you and said, man, you look just like your father, or you look just like your mother? That's because families have common characteristics. Well, these families on a periodic table have common characteristics too. They're similar. A lot of times they'll have similar boiling points, similar melting points. So they have similar properties. And that's why they sometimes will call them families. So each family has its own characteristic properties based on the number of valence electrons. Valence electrons are the electrons farthest away from the nucleus. Okay, so valence electrons are the electrons farthest away from the nucleus. So if we take a look here, first of all, when I look at here, I can figure out what element this is. It's element 18. It's argon. Now, I have to look at the electrons the farthest away from what? From the nucleus. Now, we already learned what the nucleus is. This is the nucleus in here. Okay, so this is your nucleus right here. So, are these the farthest away? No, they're the closest. Are these the farthest away? No, they're the closest. These are the electrons that are farthest away. So if I asked you how many valence electrons does this element have, and it's 18, so I know it's argon, you would have to say, okay, there's in the outer shell, and we'll talk about shells in a little bit, there's 2, 4, 6, 8 of them. So it has 8 valence electrons. Now sometimes you'll see periodic tables like this, and I like this periodic table because it's really easy for students to use. Notice they have the groups labeled 1, 2, 3, then 1, 2, and then they go all the way over to 12, and here's 13, 14, all the way over to 18. So I like this type of periodic table because it's really, really easy to use. Now sometimes you'll see some funky things on the top, like this 1A, this 2A, and then wow, look here, it actually goes to B's. But if I look over here, we go back to A's. These elements right in here are what we call the transition elements. These elements here are the main elements in a periodic table. I don't want to say they're the most important ones, but there's a little bit difference between these and the ones over here. These numbers over here are nice. We talked about valence electrons, electrons in the outer shell. I'm going to give you hydrogen. Guess how many valence electrons hydrogen has? Well, it only has one. It only has one electron, period, so it's the furthest one. But look here, number 1. Beryllium has 2 valence electrons. These get a little tricky. These a lot of times will have between 3 and 4. But if I look over here, in this number 3A, their boron right here has 3 valence electrons. Carbon, these are Roman numerals, that's Roman numeral 4, has 4 valence electrons. This one has 5 valence electrons. This one here has 6 valence electrons. 7, even though it's O, sometimes it'll be V1, 1, 1 for Roman numeral for 8. It has 8 valence electrons. And that'll be really nice to know for some of the activities we're going to do later on in class. So this one is the same thing, except here they just don't have the Roman numerals. They have 1, they have 2, here's 3, 4, and here you see your 8. So different periodic tables are labeled differently depending on what kind of information they want to be able to tell you. And this one doesn't have any of them. This one here tells you where all the gases are. Notice there's just 2 liquids. There's a liquid here, that's your bromine, and then here is your mercury. Now it's a metal, but it's a liquid metal. So how do we find out numbers on a periodic table? What does some of those numbers stand for? First of all, the atomic number. And if I looked at a periodic table, the atomic number, this right here would be your atomic number. This one right here, I'm sorry, check that. This is actually your atomic number. This would actually be your mass. Now, you got to be careful. Different periodic tables put it in different spots. Now, see here, it doesn't have the mass, but it's got the periodic or the atomic number. So you got to be careful because they're in different spots. Here, they're flip-flopped up and down. So that atomic number is very important because it tells us how many protons there are, and it tells us how many electrons there are. In fact, it's kind of like a mathematical formula. The atomic number equals the number of protons, and it equals the number of electrons. So if I want to write that, I know that P is going to equal E, which also equals the atomic number. They're all equal. And sometimes remember that. Now, I don't know if you guys like vegetables or not, but I like peas. So if you remember P, protons, electrons, atomic number, they're all equal. So for example, here's chlorine. Here's the atomic number, 17. So how many protons does it have? Well, let's remember, P, E, A. They all equal. So if I know the atomic number is 17, it must have 17 protons. And it must have 17 electrons. They're all equal. So let's take a look at this number down here, the atomic mass. Mass number is equal to the number of protons. So it's another mathematical formula. Mass number equals P plus N. P plus N. So let's write that down. The mass equals P plus N. So I know this is going to equal the number of protons, and there's 17. So this is the mass number. Now we're going to round that because it's 0.4. We round it down. So we're going to round that to 35. So 17 plus n equals 35. I'm going to solve it algebraically. So I'm going to subtract 17 from both sides. So I'm going to have n left here. Now what's 35 minus 17? There's know that. It's 18. So n equals 18. So if I ask me how many neutrons there are, I'd have to say 18. So we can always figure out how many neutrons there are, how many protons, how many electrons, the atomic number, the atomic mass. As long as we know some of the information like the mass number and the number of protons, we can figure out the number of neutrons, even though it's not usually by itself on a periodic table of elements. Now make sure if you don't understand it, this will be on the test, so make sure you ask questions about this if you're struggling with it. The last thing I want to talk about in notes today is that of isotopes. Again, we talked about elements. Sometimes elements that are the same but have different numbers of neutrons. For example, uranium-235 and uranium-238. Another common one is carbon-12 and carbon-14. These are called isotopes. They have the same number of protons, they have the same number of electrons, they have the same number of, well, the atomic number is the same. They have to be the same. Okay, that, you know, P, your P's again, they're the same. But what these will do is have different mass numbers. And if you look back at a periodic table, here's one from a periodic table, you know it's 35.45. That's because they averaged the masses of the different isotopes together. So elements that are the same but have different numbers of neutrons, these are called isotopes. Thank you, and this ends this part of our notes for today. Make sure if you have questions, please ask, and we'll start up with Chemistry Notes Part 3 in our next video.